This is our video number 2 for this Riedel 6-ton air-cooled chiller. We're going to go ahead, I put the side covers on as mentioned. We're going to go ahead and we already have power to the unit. And when you first get this unit, you should, as long as there's power to the unit, the 2 compressors have crankcase heaters around each one. You should leave that on for about 12 hours before you try to turn on and actually start chilling. So this is simply your 0-1 is your on-off power for pump number 1. Green light should come on and stay on. So you have 2 controller circuits here. The lower one is the optic circuit. Even though that will still read power, you don't need to touch it. Leave it, you can just leave it set at 32. But basically that's just sensing air in that small little optics DI tank that's not going to be used. It's the upper one here, that's your, they call the laser circuit here, that's your primary water circuit. And we have a set point range, you press set, okay, we can bring it down to, I think it's from 10 to 24, and obviously this is centigrade. So we're going to have a low of 10 and a high of 24, okay. For this test for our customer, we're going to bring it down to 15 C, which is their desired cooling range for their manufacturing application. Okay. So there'll be a delay built into the control. So again, you just press this, while you hold down the set, you press the up and down arrow key. So right now we do have it set at 15 centigrade, and it should start chilling after a time delay within the unit. So while it's delaying and ready to start to chill, we can open up the cabinet door. Thought we could open up the cabinet door. And go over some of the electrical here. So using this tool, I just opened up the cabinet door. We had the disconnect already turned to the on position here. Oh, when you first start, are doing piping and powering this unit up, you want to check for pump rotation. The easiest way to do that is you bring power to the unit, make sure you have fluid in your that primary tank, and just with that on-off button here, you just toggle on and off really quickly, just for a second. That main power and the main pump will rotate. And if you recall, that main pump was behind this door here. Looking from the top, there should be a sticker on there. You want to make sure it's going clockwise, or however that sticker rotation is showing it. And do that with a flashlight. And sometimes you might need an extra helper. I was able to do it myself. If upon startup the phase rotation is going in the wrong direction, disconnect your incoming power, and you need to bring in your incoming power through a cable here, goes up through the unit, just snakes up through behind here and up to this little conduit or this hole, and then your 3 incoming powers into the top of this disconnect here, and your ground off to the side. That is where, if the rotation's wrong, disconnect your power and change any one of those 2 leads here. Don't do anything with any of the direct pump contactors or overloads inside this cabinet. And a lot of this stuff in here, because of how we're running it, does not need to be is not being utilized. But we have our 24-volt controller transformer in here. This contactor here remains in the, or breaker I should say, remains in the red position. Okay, for your main controller power. This here is for this unit. Actually, there's a little heater inside the controller cabinet. You probably won't need it, but that's all that is a thermostat for that. These here are your 2 little temperature controllers for the heaters that are in the tank, and we'll set those to a low position, so those will not be relevant. Then we have a series of our contactors here for fans and compressors, and we have our overloads overloads here. The unit also has DI resistivity sensing. Well, that's not going to affect in any way your basic cooling for your basic application. So again, these are all our contactors and our overloads. They're all labeled by European style, like a number letter combination, 1Q2, 2Q2, 3Q2. And those, you have a substantial amount of documentation that's going to come with this unit explaining what each one of those are. So we've started to chill. And I think I just heard one compressor kick on, then a second already, and the fan comes on separately, not separately or not necessarily at the same time. In some real simple chillers, whenever the compressor is on, the condenser fan is on. That's not the case here because we're basing it off of pressure. It's not tied in exactly with the electrical of the compressor. So. Earlier I showed you, obviously we got 2 compressors for staging, and depending on how quickly we're cooling and the temperature, the controls will dictate what compressor comes on when. In our scenario here, we have a very little load, but we also have that hot gas bypass in there, so our differential is actually going to be plus or minus 1. So if we, like for this here, we set it to 15 degrees C. It's not going to turn back on and start cooling till it reaches 16. And it's not going to turn off till it reaches 14. With that hot gas bypass, we can actually afford to have that fairly tight window. If you find in the field, even with a healthy load, that the chiller never shuts off, which some people design them that way. They want to leave the compressors running almost all the time and control the cycling with the hot gas bypass capacity control. But if you find that's a problem, or you want the compressors to shut off, that blue hot gas bypass that was located behind this panel, that's one screw. You can simply just disconnect that hot gas refrigerant bypass solenoid if you wanted to reach your set point quicker and have the compressors turn off. Again, in the process cooling world, it is desirable to keep compressors running a fair amount of time, and in some cases as long as possible, or always on, even with a reduced load. But let's see here as you hear that hissing noise. So now we've the hot gas bypass turned on, and we're cooling relatively quick, and that's a fairly sizable tank because we are up at 24 C. That hot gas bypass will come on and it'll start slowing down effectively that rate of cooling to keep the compressor running longer. And with our minimal load we have here, this is probably just going to stabilize right at that 15 or 14 C and change, and just hold that temperature. Yeah, the hot gas just went off a little bit. If it turns back on, you'll hear that hissing. So now it's coming back on. And again, we have a little bit of a load inside the tank. The fans have been satisfied by the pressure, so the fans are shut off. We still have one compressor running here with the hot gas on. So right now I could be here all day just because the chiller is finding a way to maintain that temperature between the compressor running, fan going off, and the hot gas. We've run this unit for a couple weeks. It is all set to go. We're going to post this video for the customer. This is Scott from KIG. Our website is kigsales.com. Thank you.